Hi, I came across this project on the internet where they have designed an LED watch. So I was wondering how they would have done it in a PCB CAD package. If we look at the PCB layout, so here they have placed SMD LEDs on the outside circumference. These are of SMD type. We cannot. I don't think they would have placed it manually. So there should be some kind of scripting done, and this looks like it has been done in Eagle PCB package. So I recently came across a way of doing this, and I want to show it now. So let me go to Eagle. So first of all, let me open a new project. And in the new project, let me create a board. Okay. So first things first, we need to set the grid. I usually use a default grid of 0.01 inches, which is 10 mils or 10 thou, and an alternate grid of 5 mils. This is useful if something is not on grid. Okay, let me place an LED. I want to use an 0603 type of LED. So let me take a generic one. So first we need to name this LED. You take the properties tool and check the properties. For the name, we follow a particular pattern where we give a word followed by a digit. So here I choose it as LED 0, okay, which is reflected here. So now we need to take the copy tool and make multiple copies. It doesn't matter where we place them because later we'll be automating this procedure. So the whole idea is to create these many LEDs with successive numbers, which Eagle automatically does. So if you see, it is automatically incrementing LED 0, LED 1, LED 2. So that is an automatic feature which is done in Eagle. So I want to take, for creating a clock, I need 60 of them, but I started with 0, so I need LED 59. Okay. Yeah, so now we have 59 LEDs, or LED 59, 0 to 59 is 60 LEDs total. Now we're going to be using a ULP script. ULP is a inbuilt language in Eagle PCB. It is called as user language programs, and say this is the command interpreter for a ULP. So say if I type it as move here, the move command is activated. So that's how it works. So each and every command here has an equivalent ULP command here. So we will be generating a script which has multiple ULP commands, and we would have calculated all the coordinates in order to place them like this. So to do that, there is a ready-made ULP available. So all the ULPs will be bundled along with the default Eagle installation. They would be located in the installation directory. If we go to C drive and Eagle, there is a folder called ULP, and inside this you can see there are many ULP scripts which come by default with the default installation of Eagle. So today we'll be using the command raw.ulp, okay, which is a very versatile and useful script. To execute it, go to file and run ULP, and browse to that file, and it pops up this GUI. There are many options here for doing multiple operations, and here there is a small thumbnail which shows what exactly it does briefly. So there is polygon option, and there is move option, there is group. Today we'll be using the move option, which is it moves already existing components in a particular pattern, and we want to do a degree step, and we want it to be a circle, and we want to rotate each item so that it is radially placed. So in the first element option here, I'm going to be entering LED 0, because the way it works is it takes a successive number of components, so it automatically follows LED 1, LED 2, LED 3 successively. And here for X center coordinate, I'm going to be entering it as 1.5, because I'm using a light version of Eagle, so it is limited, the total area of placement is limited to 2.2 inches by 3 inches. So I need to offset the circle, and a radius I'm going to take as a 1 inch. All these parameters are in imperial units, they're in inches, and angle start should be at 0, and I want each of them to be at 6 degrees, and total of 360 degrees. It is 6 degrees because each angle is 360 degree divided by 60. Totally we have 60 LEDs all around, so we get 6 degrees as angle step. So everything is set up, just hit OK. It generates these set of commands. So all of these have a particular syntax, which is that it first moves the LED and then rotates it. So here it is moving LED 0 to this coordinate and then rotates it, and then LED 1, it moves to this angle. It would have calculated this using trigonometric functions, and this is at 6 degrees, this is at 12 degrees, this is 18, and so on. So once we hit OK, it automatically places all of these. This is really cool. So if you keep watching on the top left here, the present coordinate, so once I place it at the approximate center, we can see that it is 1.5 by 1.5, because I had mentioned as 1.5 as the center. And if we measure the diameter, so I want it to be in the measures layer, and I want it to be in inches. So let's say if I measure from LED 0 to LED 29, we can see that it is 2 inches exactly, because I had given a radius of 1 inch. Okay, so let's save it. That script is actually very versatile. We can not only do circles, it can do many other things. It can do ellipses as well. So let's say if I invoke it again, and let's try an ellipse. The radius of 1, angle 0, 6 degrees, 360 degrees, and I want a default of this. I want to rotate each item, and I want this to be, let's say, eccentricity factor of 0.5, and hit OK. Now let's see what this does. Wow, nice. So as you can see, it's a really versatile script. So thank you for watching.